Sathyabama Institute of Science and Technology.
A very good morning to everyone. I'm Dr. Noella from CSC department. Today we are going to see about k-means clustering. So the word clustering itself, you all know, it's an unsupervised learning algorithm. The word meaning is grouping. So we can tell clustering or cluster analysis, it's a machine learning technique which comes under unsupervised learning algorithm. So the unsupervised learning algorithm means unlabeled data. The definition of clustering we can tell it's a way of grouping the data points into different clusters considering the similarity between the data items in a data set. So the main thing is finding the similarity between the data items in the data set and we are dividing it into different groups. So the similarity patterns can be a shape, a size or a color or a behavior which among the different data items in a data set. So clustering we can tell it's an unsupervised learning method. So there is no supervision is required. And this method is mainly used for statistical data analysis. This is an example for unlabeled data. So it's a raw data which is given. And in this raw data, it's a mixture of different data items and what is the label of the data is not known. So what we can do? We can apply a particular algorithm to find out what is the type of the data. Here we can't give the label for the data or particular name for the data. We can group it into different groups. So this is an example. Here the different fruits are given. So three different groups are there, right? So here we can apply an algorithm and we can find out the similarity between the data in the data set and we can differentiate it into different groups. That is clustering. So the clustering technique can be used for different applications like market segmentation, statistical data analysis, social network analysis, image segmentation and anomaly detection, etc. How can we perform clustering to a particular data set or what are the different methods available? We are having a lot of methods according to the size of the data set, according to the variables in the data set and what's the type of the data set. So likewise, we can use different algorithms. We are having different types as partitional clustering, density based clustering, distribution model based clustering, hierarchical clustering and fuzzy clustering. So in this particular lecture, we are going to learn about what is partitional clustering. So in partitional clustering, here we are considering the whole data set and we are dividing it into different groups. So this is an example. This is a particular data set. We are having 4 different type of data and the class label is not known. But according to the similarity of the data items in the data set, we are dividing it into different groups. So partial clustering methods, here we are using a term like centroid based method we are using, or we can use mean for a different data items in the data set. So the algorithm we can apply in this partial clustering is k-means clustering method. So k-means clustering, an example we are going to see now. Before that, we can learn what is the algorithm for k-means clustering. So k-means as a clustering method is an unsupervised learning algorithm. K-means also it's an unsupervised iterative clustering technique because a same process will be repeated again and again to come up with the conclusion what is the group of the different data items in the data set. So this is an example. Consider this is a data set. We are having different data items in the data set, but it is commonly given in the data set. We don't know what is the type of the data or what is the group and all. But using, when we are applying a k-means clustering algorithm, we can divide it into different groups. So how it is partitioning the data? When we are having a data set, we will be having different data items. According to what or what is the measure to identify the group of the data items in the data set? We are using the similarities between the data. That is the one thing. For finding the similarity, we are using some measures. K-means clustering method. So first we have to partition the whole objects. The objects is nothing but the data items in the data set. We are partitioning it into non-empty subset. So for example, if you are having a data set of 10 data items, we can randomly pick some data items and make it as a group. So we can make it a 2 group, 3 group, 4 group. So that is a trial and error method. We can make use of any number of groups so that the group that we want to split the data, that is known as K. So that is k-means clustering method. Using k different means, we are going to group the whole data in the data set. Identifying the cluster centroids or mean points. So we have to find out the mean of the different groups that we find out, and then we have to go to the next step. Assigning each point to a specific cluster. For one specific cluster, we have to find out what is the representative for that cluster. So next step is computing the distance from each point and allot the points to the cluster. So each and every data items we have to select, and we have to analyze the point, and we have to find out the distance from that particular point to each and every cluster representative, and to which particular cluster representative this data set is having the minimum distance. For that particular group, it will be mapped. The process will be repeating again and again until you are getting the same groups. For example, we are having two different groups. In group 1, we are having 1, 2, 3 data set, and group 2, we are having 3 and 4 data set. So when we are doing the same process again and again of k-means clustering, we are getting the same groups, then we can stop it. Otherwise, we have to repeat the process again and again until we are getting the same group. So this is a pseudocode for k-means clustering. K is the number of clusters. So it is not defined like this should be 2 or 3. So according to the requirement and a trial and error method, we can find out what is the value of k. So most commonly used k value is 3, and D is the data set which is containing the n objects or data items. So method, for what we have to use, we have to find out the data items in the data set, and we have to make randomly, we have to pick the data items from the data set, and we have to make into different groups. Then we have to find out the cluster head, or we can, that's a cluster representative, and we have to find out the distance of each and every objects to the data representatives, and for each and every object which particular data head is having the minimum distance. For that cluster head, this particular data item will be get mapped. So until we are getting the same group, the process will be repeated again and again. Now we are going to discuss one example. In this example, we are having 4 data points. So data points is nothing but the data items in the data set. So the data set is considering 4 objects, x1, x2, x3, x4. x1 we are having 2 different value, 1, 0, x2 the value is 0, 1, and x3 the value is 2, 1, x4 the value is 3, 3. And as I already said, the clusters can be randomly picked. So here we are considering 2 clusters, cluster 1 and cluster 2, and we have randomly picked x1, x3 as cluster 1 and x2, x4 as cluster 2. So this is not mandatory that you have to follow the same process. If you want, you can take x1, x2 as one group and x3 and x4 as next group, and you can do the same process. So the thing is, until we are getting the same group, we have to do the process again and again. So the problem is, we have to find out first iteration. We have to apply the k-means clustering method, and we have to do the first iteration, and then we have to find out the square error. What is the error when we are selecting the clusters, and we have to repeat the process again, and whether we are getting the same group or not, that we have to go and check. Step 1, the centroids of the cluster C1, C2. So in this example, we had taken x1, x3 as C1, x2 and x4 as C2. First step, you have to find out the mean of this particular cluster. So how can you find out the mean? For C1, we are having x1 and x3. So x1, the x point is 1 and y point is 0. And x3, the x value is 2 and y value is 1. So how can you find out the mean is 1 plus 2 divided by 2 and 0 plus 1 divided by 2. That is the mean for x1 and x3. So mean of x1 and x3 is 1.5, 0.5. Same thing, we are having the cluster 2, we are having the mean as x2 and x4, that you have to connect. So 0 plus 3 divided by 2 and 1 plus 3 divided by 2, we will be getting the answer as 1.5 and 2. Now these are the cluster heads. So this is for C1 and this is for C2. So once you completed the mean, now we have to find out the error term. So how you can find out the error term? These are the newly created variables, right? So we have to find out the distance between each and every variable with this one. X and x3 which comes under m1 and x and x4 which comes under m2. So how can you find out the error term is 1 minus 1.5 the whole square plus 0 minus 0.5 the whole square plus 2 minus 1.5 the whole square plus 1 minus 0.5 the whole square. So that is for the first error term. Second error term, you have to find out the distance between this mean and its on point. So its on points is x2 and x4. So 0 minus 1.5 the whole square plus 1 minus 2 the whole square plus 3 minus 1.5 the whole square plus 3 minus 2 the whole square. Let us check whether we had computed correctly. Yes. So this is the error term with the first mean set and x1 and x3. This is the error term which is second mean set and x2 and x4. So you got this is the error for first set and second set, and you have to make the sum of this one to find out the whole error. So the total error is 1 plus 6.5, that is 7.5. So once you assigned x1, x3 as the first set and x2 as x4 as the second set, we got the whole error as 7.5. Now we have to find out the distance of each and every data point with the cluster head. So M1, that's the first cluster head, we are having values as 1.5 and 0.5, M2 as 1.5 and 2. Consider the first point x1. x1 we are having value as 1, 0. So now we have to find out the distance of x1 and m1. Euclidean distance root of x1 minus x to the whole square plus y1 minus y to the whole square. So root of 1 minus 1.5 the whole square plus 0 minus 0.5 the whole square. That will give the distance between m1 and x1. The same way you have to find out the distance between x1 and m2, that is 1 minus 1.5 the whole square plus 0 minus 2 the whole square and the square root. So we are getting 0.707 and 2.062. So why we have to find out this one? I already said the measure that we are going to use is distance using Euclidean distance formula. So here you have to check which one is having the least distance. Obviously 0.707 is having the least distance. So hereafter the x1 which comes under cluster head 1. So obviously we had already taken x1 as cluster head 1 only. So that is fine. So now we can go and check the next thing, x2, x3, x4. The same way you have to compute all those things. x2 we are having the values as 0, 1. So 0 minus 1.5 is the x1 value for cluster head 1 and 0.5 cluster head 2. Once you compute this one, you will get the values as 1.581 and 1.803. So consider these values which is less. So 1.581 is less. So the x2 data point will comes under cluster 1. So that's the difference. Earlier we had taken x2 under c2. So here when you apply the formula, it has automatically changed to cluster head 1. Correct. So same thing we are doing for x3. We are finding the distance of x3 with the m1 and m2, and we got the values as 0.707 and 1.118. So when you compare this one, this is the least distance. So x3 also will comes under cluster head 1. So the x4 is the value 3, 3. For this one, you have to find out the difference from cluster head 1 and cluster head 2. So when you apply the Euclidean distance, you will be getting the values as 2.915 and 1.803, the least distances for cluster head 2. So once you compute this one, you will get cluster 1 as x1, x2, x3, and for cluster 2, you are getting the value as x4. So we are getting C1 as these three values and C2 as those values. Now you have to start from the beginning. So now we are having, this is the cluster 1 and cluster 2. You have to find out the mean for this and you have to take the value for that. Okay, so 1, 0 was the value for x1 and 0, 1 was the value for x2. 2, 1 was the value for x3. So how you get 1 plus all the x values of x1, x2, x3. 1 plus 0 plus 2 divided by 3. And all the y values of x1, x2, x3, 0 plus 1 plus 1 divided by 3. So you will be getting 1, 0, 66. Now this is the next cluster head for C1. This is the next cluster value for C2. So once you find out the new cluster head, you have to find out the error term for that one. Already we discussed how to find out the error term. So 1 minus 1 the whole square plus 0 minus 0.66 the whole square plus 0 minus 1 the whole square plus 1 minus 0.66 the whole square plus 2 minus 1 the whole square plus 1 minus 0.6 is the whole square. Okay, so you had taken each and every x and y term and you have find out the distance or difference between these values, new cluster head. So you will get the value as 2.668. So E2 only we are having 1 point, so obviously the value will be 0. Okay, so what is the total error? 2.668 plus 0. So what was the earlier one? It was 7 point something, right? So when you compare those two, which is having the least error? This one. So the newly selected cluster was better than the previous one. Okay, so total square error is 2.668 plus 0, 2.668. So earlier it was 7.5. Now we got the new set of values and the error square was reduced to 2.668. Okay, so now we got the new values as 1, 0.66 and 3, 3 as new sender heads. So using that one, again you have to find out the distance from each and every point with this new cluster heads. 1, 0 is the value for x1 and 1, 0.66 cluster head 1 and 3, 3. When you find out the distance of this data item 1 with the cluster head, you will get the values as 0.66 and 3.46. Obviously, 0.66 is the less value, so this will comes under C1. So no change in that. Now we find out x2 with both cluster heads, and we find out this one. We can know that 1.056 and 3.46 comparing 1.056 is the less value. So x2 comes under cluster head 1. Same thing for x3. x3 value is 2, 1 and we have to find out the distance of both cluster head. So which is having the least distance? 1.056 is the least distance. So this will also comes under cluster 1. And for x4, it is having the least distance with the cluster 2. So the newly got cluster is x1, x2, x3 comes under cluster 1 and x4 comes under cluster 2. So when you checking both, the previous iteration and this iteration was same. So no need for any reassignment. You can conclude with the newly got clusters. Cluster 1 which is having the data items as x1, x2, x3 and cluster 2 as x4. So advantages of a k-means clustering. So with large number of variables, k-means clustering can be compute very fast than the hierarchical clustering. Other clustering methods, when we are comparing with the hierarchical clustering or other different type of clustering methods, with a large number of variables, this particular data can be worked very faster, and also we are using the least distance. So it can make tighter cluster. So cluster will be having more similarities in between. And the disadvantages is randomly we are selecting the first cluster head. So or randomly we are picking the different data items to one cluster. So there if our choosing of the data items is wrong or too much deviation is there, it will take too much of time to complete the computation and the quality of the clusters also will be affected. So applications only when we can use the mean or the usability of mean is there, then this particular method can be used. And we need a specific number of k. The k is unknown. Selection of k value also depends on the performance of the model, and also this can't work with noisy data. For using noisy data, we have to use some other clustering methods. So in this particular video, we discussed about what is clustering, what are the different type of clustering methods, and what is k-means clustering, and we solved a problem using k-means clustering, and we discussed the advantages and disadvantages of k-means clustering. Thank you.